In this video, we are going to look at how we name and write formulas for ionic compounds. So to get started, we're going to look at what ionic compounds are. And first of all, they are between a metal and a nonmetal, and they contain ions. So it's where a metal loses one or more electrons to a nonmetal, and so the metal ends up having a positive charge or becomes a cation, and the nonmetal ends up with a negative charge or is what we call an anion. Ionic compounds may also contain a polyatomic ion. So let's start by looking at writing the formula from the name. The first one we're going to look at is magnesium bromide. So since we are dealing with ions, we would need to first write down the ionic charges for magnesium and for bromide. Those can be determined based on their location on the periodic table. Magnesium is in group 2A. It's going to lose 2 valence electrons and end up with a positive 2 charge. Bromide is one of the halogens. It's in group 7A. It will gain 1 electron to have a negative 1 charge. When writing an ionic compound, the net overall charge has to be 0, so we have to balance the charges. We would end up needing 2 bromide ions to balance the charge of the magnesium ion. A shortcut way of doing that is to look at the charge number, and that becomes the subscript for the opposite one. Here, there's that becomes an understood one for magnesium. So our formula would become magnesium MgBr with a subscript of 2, meaning that for every 2 bromide ions, we have 1 magnesium ion, and that balances out the charges, which means that the electrons are all taken care of. Magnesium loses 2 electrons, and so you need 2 bromides for them to go to. Each one gets 1 of them. Okay. The next one we're going to look at is copper 1 phosphide. Now, copper 1, you'll notice, has a Roman numeral after it, and that's because copper is one of the transition metals that can have more than 1 charge, and so the Roman numeral here tells you what charge it has. So already we know that copper is going to have a +1 charge. Phosphide, if you look at where it is on the periodic table, it has a -3 charge. So you can crisscross that. That becomes that subscript, our understood one, comes over here. So you have Cu3P for copper 1 phosphide. The last one that we're going to look at is calcium carbonate. Calcium is in group 2A, so it also has a 2+ charge. Carbonate is one of the polyatomic ions, and it has a formula of CO3 with a -2 charge. Now, how would you know that that's the formula? Well, the easy answer is that you memorize it or you look it up on a table. There are tables in your textbook that give you a bunch of different polyatomic ions, their formulas, and their charges. There are about a half a dozen that you need to memorize for this course. Those can be found on the study guide, the reading guide for this chapter. So make sure that you memorize those polyatomic ions. Quizzes and exams will be limited to those polyatomic ions that you are expected to memorize. However, homework may ask about other ones that are not on the list but are in your textbook. So make sure that you're aware of where you can find that. Okay, so here we have calcium has a +2 charge, carbonate has a -2 charge, so they cancel themselves out. We just need a ratio of 1 calcium ion for every 1 carbonate ion to have a neutral atom. So the formula for this is CaCO3. Next, we're going to look at writing the name from the formula. So the first one we have is CaCl2. We simply write the name of the metal ion first, and then we write the name of the nonmetal, and we change the ending to IDE. So this becomes calcium chloride with an IDE ending to it. Next, we have AlOH with a subscript of 3 on the outside. So our metal is aluminum. OH is one of the polyatomic ions. It is, the name of it is hydroxide. So the name of this is metal name, aluminum. And then the name of the polyatomic ion, you don't change the ending at all, is hydroxide. So that compound is aluminum hydroxide. Okay, this one has a copper in it, and copper is one of the transition metals that can have varying charges. So we're going to have to first determine what charge this copper has so that we can include that as a Roman numeral in the name. We do that because we know that overall our compound here has to have a neutral charge. So whatever our negative charge is has to be equal to our positive charge. So we're going to determine how many, what our negative charge is from our anions here. So we have a phosphate. This is one of the polyatomic ions. Having memorized it, the charge of this polyatomic ion is -3. Well, we have a 2 as a subscript outside of the parentheses. And so that means that we need, or we have 2 of those to balance the charge. So we need 2 of these -3. So that gives us a total of a -6 charge from those 2 phosphates, which means that our coppers have to give us a total of a +6 charge so that they overall have a neutral compound. We have 3 copper ions, so we can take our +6 charge and divide that by how many we have, 3. So we end up with each copper having a charge of +2. Write that as your Roman numeral, so copper, oh, forgot my R, 2 phosphate. Okay, so that is how you can write the name from the formula. Make sure that if you have a transition metal that you determine its charge first, so you can include that as a Roman numeral. Otherwise, it is simply the metal name first and then followed by the nonmetal with the ending changing to IDE or the name of the polyatomic ion.